Let's start by analyzing the simplest of linear equations, which would be y is equal to x. Or if you were part of the conversation about Euler in his writing convention, we can use function notation to say f of x is equal to x. And I mean, if you like, you can think of y or of f of x. This is just a fancy way of saying y. But let's take a look either way, whichever one we're talking about. Let's see what happens when we create a table of values for x and either y, or if you want to call it f of x, that's fine too. Well, the statements, either statements say that y is equivalent to whatever x is. So if I decided that x was -2, say, then y is equal to -2, which is to say that I would plot my y value also at -2. If I were to say that x is 0, well then let's find out what the f of 0 is, and the f of 0 is 0, so then I would put my y value, or my f of x value, also at 0, and the same would be true if I had a positive 2. A positive 2 would generate a positive 2. Now when we talk about all the possible x values, we're talking about the domain of the function, right? Now I've only listed 3 x values, but you can see that because I can really substitute any value in for x, then my domain of this function would be all real numbers. By the same token, we can talk about the range of the function, and that would be all the y values, everything, all the outputs to my domain. So if I input into the function, if I input a -2, the f of -2, then my output is a 2. If I put in the f of 2, then my output is a positive 2. So the range is all of the outputs per inputs. And as you can see, in this function I have a 1-to-1 input to output ratio. So what does this mean? What this means is, if I were to create a graph, I'm doing this freehand, so please forgive any messiness, and I were to call this my x, and this my y-axis I could call my f of x or my y. Either way, either notation is valid. To graph this function, y is equal to x or f of x is equal to x, then I would just say, well, if I had a 1 here, or actually let's use our values here, I have a -2, and then I would go -2 from the origin, and then -2 down, and that would be my first point. This point here would be 0, 0. Let's do these in a different color. Let's do these in yellow. So there's one point there, -2, 2. My next point would be 0, 0. And then finally, the other point would be 1, 2. The other point would be 2, 2. Now clearly these points line up to form, and I don't have a straight edge I can use here, they form a line. And what that line means is that all values along that line are possible substitution values for my function. I can choose the point 4 and 4. And that would make my statement true because the f of 4 is 4, or when x is 4, then y is equal to 4, right? So a linear equation is one that is the line described by having a y and an x that are both in the first degree, neither of them have an exponent, or having a function in terms of x also in the first degree.